Let us have a comparison of the electro and magnetostatics. Together with the boundary condition E tend to 0 far from all charges, from the Maxwell's equations, if the source charge density ρ is given, we can calculate the field, and this essentially contains the same information as Coulomb's law plus the principle of superposition. In magnetostatics, the divergence and curl relations are del dot B equal to 0 and then del cross B equal to mu 0 J, which is known as the Ampere's law. Together with the boundary condition B tend to 0 far from all currents, Maxwell's equations determine the magnetic field and they are equivalent to the Biot-Savart law plus the principle of superposition. In both cases, the Maxwell's equations and the Lorentz force law constitute the most elegant formulation of electrostatics and magnetostatics. Regarding the nature of electric and magnetic fields, electric field diverges away from a positive charge, whereas the magnetic field lines curls around a current. The electric field lines originate on positive charges and terminate on negative ones, whereas magnetic field lines do not begin or end anywhere. To do so, the divergence of B has to be non-zero. Magnetic fields typically form closed loops or extend out to infinity. From Gauss's law, that is del dot E equal to rho over epsilon 0, we infer that electric charges or electric monopoles exist, whereas magnetic monopoles do not exist as del dot B equal to 0. Let us now compare the strength of electric and magnetic forces. Typically, the electric forces are enormously larger than magnetic ones due to the sizes of the fundamental constants epsilon 0 and mu 0. In general, it is only when both the source charges and the test charge are moving at velocities comparable to the speed of light that the magnetic force approaches the electric force in strength. So these are the major comparison of electro and magnetostatics.